I already know one place where you might get stuck, and we need to talk about it. And that's partially why we didn't finish notes yesterday. It's a little bit stuffy in here. The middle schoolers are gone. Let me get the door open. But we are in 7-2 yesterday. We were technically landed on a problem where we needed our graphing calculator. And I kind of set it up. I just didn't finish it. There was one that we could have used our calculator on earlier. I chose to do it by hand, and I made a silly mental math mistake, so slow this down a little bit. But that's definitely something that could happen to you guys in homework, too, right? Sometimes using the calculator will take longer, but then it's going to be a bit more precise. Sometimes doing the mental math will go faster, but it opens the possibility for making mistakes. But this one, we did try to do elimination because that's technically the section. Once again, you can try to do substitution if you want. You could solve for x squared and plug in. I wouldn't solve for y because then you'd have to FOIL it. I think elimination might be the easiest way to go. But the struggle was we landed on something ugly. So I put a ... but I don't know if you guys saw any quadratics in homework. I just need to make sure if you do, you know what to do. So how do we solve this quadratic, guys? You're a human, which means, oh, stink, you have options. A computer would probably just go to quadratic formula. Do you want to try the x method? Yeah. Okay. Then we do the x method. 3 times 75 is what, 225? Double check my math. I made a mistake yesterday. Adding to be 16. The bummer is that 15 and 15. That doesn't help. It's also 5 and 40. That's not going to help. Anybody find anything else? 5 and 15 or 10 doesn't go in. As you guys are pondering the x method, guess what I'm going to do? Huh? Ooh, 25. That'd be nice if it's a negative 9. Does that work? Yeah, 9/4 would be 225. Well, then throw away my quadratic formula, even though it would have gotten me there. Sure wouldn't have been fun. So then we end up with, would you guys have done your modified x method and thrown a 3 up top and reduced that to be a 1 and a 3? We have 3y plus 25, and we have 1y minus 3 equals 0. So y equals positive 3 and negative 25 thirds. Now, first of all, not good solutions, because solutions are intersection points, and intersection points have x's and y's. So right now I'm like, bummer. All right, I got the y, but I need the x's. The question, if both of these y's have x's, that could be kind of tedious. Why am I going to time out and pause right now and be like, oh, guys, don't worry about that one. Save yourself some time. This one's extraneous. How on earth was I able to know that? It's going to save me time. Instead of plugging in and finding 4 points, I'm only going to find the 2 true points. But how did I know that? What's it mean to be extraneous again? You're a little like mumbling. Yeah, it looks mathematically, it looks like it should have worked, but it doesn't fit. It doesn't work. It doesn't. I like your logic. You're seeing, well, the 25 doesn't. There's an easier way of thinking about it, though. What graph is this? Oh, this one's a parabola, true, but what's this one? A circle. How wide does the circle go? 5. X's and Y's, is that as far as it can go? What's this? Negative 8 point, it's not in the circle. So one way is a restricted domain. This right here, just because I know it's a circle, I know both my X's and my Y's are going to be between negative 5 and 5. It's not quite as straightforward as a square root or a log, where square roots can't have negatives, logs can't have zeros or negatives, but it still is saying, but my x's and y's can only be between negative 5 and 5, and that's it. I only can be in that circle. Another way of thinking about it is, it's not solving graphically, but it is thinking about it graphically. If I have a circle centered at 0, 0 with a radius of 5, and if I have a, solve for y, an upwards facing parabola. How many intersection points can it actually have? Oh, but you had to. This would have made 4. Why would it have made 4? What happens when you plug in y equals 3? Plus or minus square root. Exactly. If I go plug it in. There were a couple different things to show us that this was not going to be so, well, it wasn't going to work out so well if I tried to solve for both of those. I would have gotten x squared equals 16, x is equal to plus or minus 4, so my intersection points are 4, 3, well, could have done a plus or minus 4, but that's okay. What would have happened if we had tried to plug in negatives 25 over 3? I would have plugged in, I would have subtracted, and I would have had a square root of a negative number. So the math would have told you that too. You would have had imaginary numbers. But if you understand the context of this dude being a circle, well, he's too big. Never mind. Just depends on where your brain would have caught it. Some of you might not have caught it until you went to plug in. But that was our first extraneous answer that's come around in a while. This guy, why do I have a y1 and a y2 written out though? You see me. I keep on doing like by hand math instead of my calculator. Why all of a sudden am I like, oh, what's different? There's an e with a polynomial. I got nothing. If I do an ln, yeah, if I do an ln, then this guy gets stuck. If I try to add the 1, then that x is still stuck. Like, I can't just tackle the e and ignore the polynomial. I can't just tackle the polynomial and ignore the e. There are some times, especially when you have exponentials, logs, and polynomials, trig, they don't match necessarily. If I have trig with trig, exponentials with exponentials, logs with logs, yeah, I can do that. Polynomials with polynomials, yeah. But not when I start mixing them. So that's when we would go here. Ooh, I have all sorts of fun BC stuff in here. Sorry. I need to like make a feature that says clear that all out. I'm sure there is one somewhere. But you could do it 2 different ways. You could go ahead and graph these two and say, okay, x minus 1 and e to the x. You might not really see any point to me taking time to show this, but just trust me. I know it's in y2 and y3. Trust me, there's a point to me actually taking time. If I was to graph, I don't like my zoom anyway, but most of you would have been in zoom standard. Is that good enough? What are we supposed to be looking for? I added down x plus 1 equals e. X plus 1. Maybe I should do my math well. You guys saw we were running out of time yesterday. Okay, well, once you do your math right and you actually get the correct function, now let's see if it's better. Okay, can we see the intersection? Yes. But didn't you have in section 7.1 some weird like businessy problems where the answers weren't like in the 10 by 10, but instead it was like $16,667 when your commission is better than whatever? You would have to zoom out, zoom out, zoom out to get there. You could, whenever you're solving something like this, you could graph the two and look for the intersection point, but there's also a cheat to some degree. You're cheating the calculator, or you're cheating, well, you're saving time for yourself, I should say. The other way of doing it is that you could actually just move the e to the x and look for the zeros instead. Because I know the zeros are going to be the x-intercepts. I don't have to go looking out in space somewhere. I know to stick right around that x-axis. Now, I know it doesn't make a big difference in this one because Zoom standard was good enough. I get it. I'm just knowing messier problems are coming, especially in AP Cal, where some of the word problems or some of the solutions are way off this normal, like, Zoom standard grid. And so it's going to look totally different because I'm not seeing the line and the exponential. I'm seeing them all put together. But the answer is going to be at the exact same place because instead of looking for the intersection wherever it may be, I can say I'm looking at the axis. Wherever it hits the axis is my answer. So yes, you can find the intersection or you can find a 0. Either one will lead me to the proper x term of this occurs when x equals 0. And I can go plug and chug. Anything to the 0 power is 1 by back substituting. So guys, we back substitute with substitution, we back substitute with elimination. It's just a thing. But a second ago, Ivy brought me a problem and said, my group's not there yet, so I need to ask you because they're not ready. And it had to do with this page. It had to do with this page. So far, we have talked about problems like this. Wherever he is. There he is. And kind of problems like this. But not really problems like this. Now we're going to zoom in and try to figure out what's going on. First of all, we should see some ding 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 just from the picture. Because what's true if these are actually parallel lines? What's true about them with intersection points? How do you know whether they're truly parallel or whether it's just like really zoomed or barely different to where they might eventually cross? What do you need to know or what do you need to see to know that they're truly parallel? Truly parallel lines have the exact same slope. I'm going to go back to the top in just a second, but how can you know whether or not this has the exact same slope? I don't even see slope, do you? Not yet, exactly. So what do we need to kind of think of as we're thinking about these questions of what does it take to be equivalent or consistent or inconsistent, especially, I should say. Just remember that slope comes from y equals mx plus b. This is the easiest one because this one, if you know they're truly parallel, you can be like, sweet, why go solving? The answer is none. But my question is, what if you didn't see a picture? What if you didn't see the slope and you just said, elimination? How is that going to show up? Would you guys have multiplied everything by a -2? I mean, you could have multiplied by 3 and 2, but that takes too much work. What happens if you tried to do elimination? What if you didn't have a picture? What's it going to look like? What's going to happen? Uh-oh. Doesn't it look like it has an intersection point? What if we were to rewrite this in y equals mx plus b form? Y equals -2x over -3. Wait a minute, is this truly parallel? This slope is 2/3. What's this one's slope? Now what's the dilemma? What can you guys tell between the equation and the graph? Are they the exact same thing? No. Which means these equations do not model that graph. And I don't know exactly why not. That's weird. I think he was hidden. I just meant to hit him and I accidentally hit both. So let me get rid of him real fast. Because it doesn't even, oh. I'm not even using Acrobat Reader, but it stopped working, whatever it is. That's cool. That's cool too. Okay. Your book that we didn't use just went away. Sorry, if you guys have homework questions, we'll get back to it. We hadn't gotten there yet anyway. Let's get away from that dude. Because that dude doesn't even model this equation or this system of graphs. But instead, the crazy thing is I think I can still make the equation even though that one wasn't the right one because I can see the intercept. And the intercept would be +1. My slope looks to be down to, right? 2? No, it doesn't work. Down 1 over 2. So that would be 3/2. 1/2. Okay. This other one has an intercept of -1 we'll have him be the exact same slope. Okay, so if you were to see this, I mean, you guys could go ahead and then see, like, oh yeah, they are the same slope. So if it's written in this form, it wouldn't have been that bad. But the problem is they're not going to give it to you in that form. They're not going to give it to you in the mx plus b form. So if we saw it like that, parallel, no solution. If we saw it like that, parallel, no solution. But what would the system maybe actually look like? Well, the x would be on that side, number 1. Probably wouldn't be fractions, number 2, unless they were being really mean. But we could go ahead and put it as a fraction. I guess that's not completely crazy. You guys saw some fractions in 7-1 homework. But what if they also had something maybe without the fraction? To where we would have and I just got that by multiplying everything by 2. So I could have had a 2y and a 3x that was subtracted and then a negative 2. What would have happened if you had tried to do elimination? That's what I'm trying to get to. What's it going to look like if it just shows up in one of your problems? Yeah. That's going to be a positive 3x minus 3x is going to equal 0. That's going to be a negative 2y plus 2y is going to be 0. And then that's going to be a negative 2 minus 2 is negative what? Is that true or is that false? Does 0 equal negative 4? Never. Whenever you get a false statement, all the x's, all the y's cancel out. That false statement is telling you there are no intersections. There's no possible way that these can ever come together and be true at the same time. That's a false statement. Now, Ivy, what problem were you asking me about? That one wasn't a false statement. That was a 23. It's also possible that you might get a true statement. A false statement says inconsistent. This system is inconsistent because there's no solution even possible. And it might mean parallel lines or at least non-intersecting graphs. But there's also some weird stuff that could happen with consistent too. Now, to some extent, consistent might not be a big deal. It's like, whatever, there's an intersection point. That's normal. Okay, cool. Let's go find us the x and the y, whatever it may be. However, what's this picture trying to say? I don't see two graphs even though there are two equations up above. I don't see two graphs even though there are two equations up above. I'm going to go ahead and get rid of these equations just because I'm a little wary since those other ones didn't match up so hot. And let's zoom in. These were two different equations. We would have solved for an x and y. We would have been good. This one, then? This one's infinitely many. Sadly, I can't say all real numbers. Well, I kind of can, but I kind of can't. Infinitely many, but it's not all possible points. It's only all points that are on the, which are infinitely many. There are infinitely many points on the line. But it's not like that. That's not an answer. That's not an answer. That might be an answer. That's not. So it's not all, literally all points. But there are going to be answers for all x's. And why is that? Because you are going to get a true statement. And let me give you some examples of true statements. One of the most common ones is 0 equals 0. What if everything goes away and what you're left with is 2? Is true. Not like 0 equals 0 or 5 equals 5 or whatever else you want. It is possible that everything cancels out in a good way, which will lead you to, oh my goodness, it's the same line. And that's this vocab word at the very top of the page, equivalent. However, sadly, it's a little zoomed out for you guys. My question is, which one, the other, or both? Which of these are equivalent at the very top of the screen? And how can you tell? Maybe I should just get rid of all my examples on this page because the whole page stinks. Neither of those are equivalent. I'll give you another one. Why is this an equivalent statement? I'll give you a good one. What makes it equivalent? If you multiply the top by 6, you get the bottom, or if you divide the bottom by 6, you get the top. They're the exact same thing. Oh, no. So every single problem we need to like pause and compare the two and see whether or not they're the same? No, you don't. But there is just this possibility of this equivalent situation occurring. And if it does occur, maybe you'll see like, that's weird. They look really similar. And if it does occur, that's when this whole infinitely many situation happens. Which is still solutions. It's still a consistent solution. There are answers. That's great. But this equivalent guy says, yeah, not just are there solutions. There are infinitely many solutions. And so if I was to do elimination, if I was to multiply this whole thing by a -6, I would end up with 0 equals 0, which would point me to that case. So consistent and inconsistent. These are two big old categories of answers, no answers, but equivalent systems, well, they're all the same thing, so I guess they're answers, but the answers are just themselves. There's a snazzy way of writing it that we'll kind of talk about. Maybe we'll go peek at number 23 if the Acrobat reader decides to, I don't know, randomly be happy again. But those are just some different vocab and different ideas of what could happen that could be weird. This one's the most normal guy. The one solution is the one that you're used to. You solve, you get an X, you get a Y. For lines or maybe for other guys, you get more than one answer. But these other ones are like, ooh, what else could happen? False statements, true statements. That's weird. Griffin, what's up? Yeah. Before we get into that application, we have one word problem to finish the section, and then we're done. Let's go find that one that Ivy was talking about, which is number 23. Because to be honest, even though infinitely many isn't a bad way to at least kind of explain what's going on, it's not the full answer. I think so. But you guys should have the homework written down because I gave time at the beginning of class, so you tell me.
I don't think it is.
It's not? Ivy, are you sure it was 23 or was it a different one? Oh, bummer. You did an extra problem, Ivy. But that's okay. We'll just use it as our example. Because it was a good one, and it is from homework exercises. It just might not be one that you guys have to do. So that's all right. We'll just throw it in here in our examples instead of us going over it. So this one, you guys were just watching me do elimination to other ones. I'm guessing most of us would do 4, yeah? Negative 4? I already have it. Oh, I was thinking this one. Were you thinking that one? I like them being opposite signs so I can add down. Oh, you just want to make them look the same. Got it, got it. I was doing elimination because, to be honest, I don't really think ahead. Except Ivy showed me, and so I already thought ahead, so I knew what it was. But a lot of us, don't we just get to the elimination zone and say, okay, whatever, let's go? So then negative 20x plus 20x is 0. And then 24y minus 24y is 0. And then negative 12 plus 12 is 0. But here's my question. If I say that infinitely many is a good description, and yet it's not the answer, what would the answer be? Infinitely many is a good description. It's not the answer. Not 0, 0. But that's not what x or y equals. 3 comma 2? Oh, give me a second, let me check. Why is 3 comma 2 unanswered? Although if we go that route, it's going to be dangerous. Why does 3, 2 work? It makes sense, and if you plug it in, negative 15 plus 12 is negative 3. But here's the dilemma. How many answers do we have? So do you want to list them all? Yeah. I do, but I don't want to actually write them out. I would rather have a formula. How do we have a formula? we say, you know what? There are infinitely many, so I'm going to let my x be a variable and say, you're a. What's a? All real numbers, negative infinity to infinity. But if x is a, it has to be on this line. It can't just be any random point to go with that a. So we have to go ahead and throw this guy in and say, okay, well, what if x can be anything? Infinitely many, x can be anything. Now, we plug in and say, okay, well, what's negative 5 times anything plus 6y? So what would y equal? So let's take Nathan's. If x is 3, 15 minus 3 is 12 over 6 is 2. Hey, that's good. But what if x is 4? Well, if x is 4, it's not quite so pretty because then it's 17/6. If x is 5, well, that's not so fun either because then that's 22nd 6. But still, all of these are solutions. Nathaniel, yeah, it was good. You got one right one. But to find all the other ones, I think it'd be a lot easier to have a little baby formula to say, oh, all of those are the right ones. Infinitely many, yes. But which ones? Well, if x is... Now, hold on. Technically, we could have been super snazzy and gone... I don't know if it's super snazzy. We could have gone the other way. And said, guess what? Y gets to be anything too. Okay, cool. And we could have gone the other way, plugging in y and solving for something in terms of x, which would have been not quite as much fun. But it'd be 6y plus 3 all over 5, I think. Because you would subtract. Oh, did I do y? Thank you. 6a. So you double check. What if y was 2? That'd be 12 plus 3 is 15 divided by 5 is 3. Works either way. And both of them still explain the exact same data points or the exact same set of numbers. Or set of ordered pairs, I should say. But anyway, that's a little bit beyond. Because in Algebra 1, you guys just learned the infinitely many. No solutions. One solution. All solutions. Infinitely many. You learned that way back in Algebra 1. But now it's like, well, we can express those answers. It's not all points. It's just select few that are on the line. Anyway, Ivy, good question from earlier. What happens if you get 0 equals 0 or any true statement? Infinitely many, but either y or x needs to equal a. So as we finish off with this last quick application problem, I think it's an easy one. I said this yesterday in class. You might have caught it, you might not have. It was from section 7.1. We will need a system to solve a word problem or a situation if we have more than one unknown or more than one constraint. More than one unknown means we have more than one variable in old school language, or in simpler terms, and more than one conditions that need to be satisfied. There are our equations. If we have conditions, we make equations, and if we have unknowns, we make variables. Like yesterday with the money being put into 2 different bank accounts. How much money do you have? That's one condition. Make an equation out of that. How much interest do you have? That's a separate condition, so make that a separate equation. It kind of just gives you an idea or a way of breaking down information. Different conditions make different equations, different unknowns make different variables. So I kind of lead this into one quick word problem. I'm just curious, can you guys find the multiple conditions and can you find the multiple variables? Then we'll try to figure out the system to solve. So if I dual page it, let me a little bit zoomed out and make this guy back if you want it. An airplane flying into a headwind travels the 2,000 mile distance between Chicopee, Massachusetts and Salt Lake City, Utah in 4 hours and 24 minutes. On the return flight, it travels, let's just pretend, the exact same distance in 4 hours. Let's assume the wind has not changed. Finding the airspeed of the plane, find the airspeed of the plane and the speed of the wind, assuming they both remain constant or that both remain constant. What are our 2 different unknowns and our 2 different conditions? Who's what, what's who? This is really just a system of 2 equations, but how do we make it? Direction? What about direction? You're flying. Direction, magnitude, vectors. Uh-oh, we're back in chapter 6. Well, 8 in chapter 6. Hang in there. But the rest of us, we're in chapter 7. What are our unknowns? Okay, airspeed and speed of the wind. So we can have our two unknowns be airspeed of the plane. Let's just make that, what do you guys want to make it, A or P? X? Sure. Okay. But if we have two unknowns, we need two conditions. So what are our two situations, our two conditions, our two constraints, our two known pieces of information? We do know with a headwind, actually I should say into a headwind. Is into a headwind good or bad? Why? How can you tell just from the problem itself? Takes longer, slows it down. Do you see it? So when it says into a headwind, that means that you are pushing. It's like you're trying to swim upstream, right? Or it's like you're trying to run into the wind. It's going to be harder. The plane is flying directly against the wind. So into a headwind, they're working against each other or opposite each other. And then if you turn around, if everything stays constant, well, now all of a sudden they're working together, right? So I can say they're working opposite and then they're working together. The wind is slowing it down or the wind is speeding it up. But this is speed and speed and speed and speed. Wait a minute, I need to set this equal to speed, but what's the hints that they gave me? Distance, how far, and time, 2 times, how long? Well, I need how fast. What do you guys think the measurement of speed is going to be? Distance over time, miles per hour. Oh, that makes sense. Yeah. Okay, so wait, I need that's the miles per hour, that's the miles per hour, miles per hour, miles per hour. I need a miles per hour of how fast it was going on the way there and how fast it was going on the way back. How am I supposed to know that with knowing the distance traveled and the time it took? And P.S., it already said it. What'd you say? Yeah. So, question, what was the distance covered and the time it took on the way there? 2,000 over? Ooh, good. Not 0.24. Come on, think critically. It's not 2400. It's 24/60ths. Right? It's not 2400. It's 24/60ths. So I guess I could do 4 and 24 over 60. You could convert hours to minutes, but if I want miles per hour, I don't think I'd be miles per minute. That'd be kind of awkward for a plane. I could do 4 and 24/60ths. I wonder if that's anything nice. Come on, my mental mathers. But then this one would be 2,000 miles per 4 hours, right? That one's easy. This one's 500 miles per hour. 2/5, aka 4.4? Wait, 4.4, sorry, 2,000 divided by 4.4, right? So that'd be 4 and 2/5, which would be 4, well, let's take it in hot refraction. That'd be 22/5. And then if I switch it, 22 doesn't go in super nice. That's okay. Well, let's do 2,000 divided by 4.4. What's the point? What do we now have? A system of equations, and can't you just add down? So we have our 2x is equal to 2,000 divided by 4.4 plus 500. Can you figure out what the plane is and what the wind is? Yes. It did take a little bit of work to figure out sometimes it's easier to figure out the 2 variables, then you try to make the conditions. Sometimes it's obvious the conditions and you try to make the variables. But anyway, guys, it was kind of nasty, the whole headwind thing. You had to use the physics idea of distance equals rate times time, or rate equals change in distance over change in time. You had to do a little bit of dimensional analysis to change the minutes to the hours, although you could have gone hours to minutes. Hopefully no one went to seconds. That would be crazy. But then that would work out just fine. Now, I just said we had to get into 7.3. It's close. I just said we had to get into 7.3. The nice thing is we kind of covered a homework-ish question. Sadly, it wasn't an actual homework question. I thought it was going to be. You guys did see that whole true-false thing. I'm just curious if you guys will be able to circle the right one at the beginning of tomorrow. The right one? I thought it's just whichever one I thought's better. Okay, well, let's see if we all agree. Which one's better? The one on the right, definitively. Why? Why is it shorter? I got it. I plug it in. I got it. I plug them in. I got it. Guess what this form is called? Do you guys remember at all last year with matrices, there was this cool way of making a matrix solve your systems of equations for you when it was possible and they weren't infinitely many? We never got to use that cool RREF trick in your calculator with matrices. We're going to talk about why the programming and how the programming does what it does. Now, we're not even in matrices. That's chapter 8, but we're starting with systems of equations just with the idea of, would we rather it look like that or like this? We all can agree. Like this. Why? Hopefully it's self-explanatory. But how? Here's the crazy thing. They're the same thing. Guess what you're going to be given? Guess what we're going to make it look like. Why? Once we make it look like this, it's just like a boom, boom, done. Well, a boom, 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 done. But either way, our job, our goal for tomorrow is to say, we want this, so let's make it the exact same way. Well, not the exact same way, but similar to in algebra when it was like, we needed a perfect square. We didn't have it. Let's complete the square and bring in extra stuff to make it what we want. Don't worry, it's not complete the square, but it's similar. How do we, as creative human beings, say we want that, we have that? Is there a system? Is there a procedure? Definitely. We'll see it tomorrow. That way, when homework gets a lot harder, we'll have a way that we'll all be taking to make it a lot easier. All right, guys. I am missing all my books, so all of you that throw them all around the room, if you wouldn't mind bringing them back, that would be awesome.